are doing lessons 8.5 and 8.6 today. And again, I'm so sorry that I wasn't in class this week or last week and kind of throwing you off. I hope you were able to catch up. I am doing this lesson, just saying, on like 3 hours of sleep, maybe 4. So if I mess up, that's why. I got my coffee here, setting the vibe with my Valentine candle going. And so I'm ready, hopefully, to be strong for y'all on this lesson. So make sure you print the notes out. It's going to be a lot easier if you have the notes out in front of you here. I'm just going to go straight from the book, but try and simplify it for you. So lesson 8.5 is on multiplying radical expressions. So the product rule for radicals can also be applied to multiple larger radical expressions. So we've got this right here, just an example from your book. It's the same as multiplying what's on the outside of the radical sign, the 3 and the x, and then what's on the inside, the radicand, 6 and 5. So this is going to end up being 3x times the square root of 30. That's probably a little small for you, I'm sorry. Okay, then we have another example where we have the square root of a times, that's just being the multiplication sign there, the square root of a. So it's going to be the square root of a squared. Well, that's going to be a. And that's that answer. Okay, so just kind of remembering, like the result of multiplying any square root by itself just equals what's in the radicand. Ends up being that. Okay, so let's look. There's some different expressions here that I think if we can have a little cheat sheet like this with notes on it. It's also in your book. I guess if you don't want to write all of this, you don't have to, because it is in your book, but sometimes writing it and doing it can be really helpful. So let's start with the distributive property. 3 times the square root of 2, and then that's going to be multiplied by square root of 5 plus square root of 3. So this is our problem. So we're going to do distributive property, which is, remember, where we multiply what's on the outside of the parentheses times each of these. My pen looks like it might be running out a little bit. So this times this would equal, or it would look like this, I guess I could say, 3 times the square root of 2 times 5 plus then this times this, which would be 3 times the square root of 2 times the square root of 3. And so I'm going to combine those two before we go ahead and see if we can add them. So this is going to be, I think I messed up. This is supposed to be the square root of 5. Sorry about that. So what's inside there, so it would look like this: 3 times 2 times 5, which equals 3 times the square root of 10. And then we remember that from this up here, where we multiply what's on the inside of each and what's on the outside of each. So we multiplied with the radicands. Okay, then we're going to add it to, and this is going to be 3 times the square root of 2 times 3. So it's plus 3 times the square root of 6. And there's no way we can simplify that, so this is our answer. I'm going to get a new pen. Okay, I'm back with the new pen. So now we're going to do the FOIL method. So that was just distributive property with those. Now we're going to do the FOIL method. So our problem is 3 plus square root of 2 Okay, there you go. And you can either pause it as you write it down. I think sometimes it's probably more confusing if I try and tell you what the problem is as I'm writing it. So the FOIL method, remember, we do first, that's for the F, which would be
I'll write this out actually. It might be helpful if you just write this out to remember. And so that's going to be 3 times 5. So for F, we get 15. And then we're going to get O, which is the outer one. So the outer one's in both. So we're going to get minus 3 times the square root of 3, because I'm multiplying those two. And then we're going to do the inner, so that would be these two. So that is a plus 5 times the square root of 2. And then we're going to do the last. So I think it's helpful if you remember there's 2 lines or arcs or rainbows here, and then 2 arcs or rainbows, I guess they'd be upside down, 1 smiley faces, if you will, here underneath. So the last 2, that's going to be square root of 2 times square root of 3. So they're both radicans, but there is a subtraction there and an addition there. So this becomes minus, and it's going to be 2 times 3. Now, this step can be skipped if you understand this and you know automatically. You can go straight to square root of 6 if you want. Now I'm just going to simplify it. So I have 15 minus 3 times the square root of 3 plus 5 times the square root of 2 minus square root of 6. And this is your answer. You can't simplify it any more than this. So this is your answer. So you could go straight from here to here if you knew to multiply those two, but I want to just show you each step so you see how I got that. Okay, now we're going to multiply conjugates. And remember, that's where you have the same numbers or variables in here, but they just have a different sign. So now it's x plus square root of 5. So on this one, the O and the I, if you remember on this, the O and the I get canceled. So I don't know, maybe you could write something like this and like put an X through it, because you're really only doing the first and the last. That's when you're multiplying conjugates. So they're the same here, binomials, but they just have a different sign. One is subtraction, one is addition. So you only do the first, which would be x squared. And then you do the last, which would be these two, minus square root of 5 times 5, which you could just write 25 in there if you understand that. I'm just showing you every step. So then you have x squared minus square root of 25, and the square root of 25 is 5. So we're going to keep simplifying it down to x squared minus 5. So maybe this would help you to remember by crossing the O and the I. Okay, then we have squaring a binomial, and that's when you have 2 binomials and they're exactly the same. So in this one, it's 4 times the square root of 2 minus square root of 3, and we're going to square that. So the first thing I do to visualize it, the problem, I'm going to write out the whole thing. Oh, forgot that square root. And then from there, I think the easiest way for you to do it is just to kind of FOIL it. We did go over squaring binomials, but sometimes when you're adding in the radical signs, it could just get confusing. So you can either do the FOIL method because you're familiar with that, or you can try and do this method where you have, you've got 2 of these, because if we do FOIL, we've got first, right? So we're multiplying those 2, so it's going to be 4 times the square root of 2. There's going to be 2 of those. And then we're subtracting, then there's going to be 2 of these, this and this. So this is the inner and the outer, so the O and the I, and they're going to be the same. So it's 2, I'll put in parentheses, 2 times 4 times the square root of 2 times square root of 3. And then your outer, so a minus square root of 3 times a minus square root of 3. So So it's looking like this. So really showing your work on these problems is going to be absolutely key. Okay, so if we're going to square this right here, think about what that would mean. That would mean that this is going to be 16, and this is going to be square root of 2 times square root of 2. That equals the square root of 4. And the square root of 4 is 2. So this looks like 16 times 2. That's going to be that section. And then what you're going to have here is, this is going to be 4 with the square root of 6, and you're multiplying that by 2, so it's 8. So 2 times 4 is 8. Square root of 2, square root of 3 is square root of 6. And then this is going to equal the square root of 9, which we know is 3. So this right here, it's like this. If that helps you to solve it. Okay, and then we're going to continue simplifying. So 16 times 2 is 40, 30, 32. Again, little sleep here. 32. So we've got 32 plus 3 is 35. So 35 minus this right here, 8 times the square root of 6. And that's your answer. Can't simplify it anymore. Okay, let's keep going. Pause it if you need to look over what I've done. Remember, if they're inside the radican, you can multiply them. You just always need to simplify. And if it's outside of the radican, you can multiply those together as well. You just need to simplify. And then pay attention to when you have things like this, where you actually have a perfect square there. So after multiplying, it's possible to simplify the product by either removing the perfect square or combining like radicals. So I'm going to show you. So if you have the square root of 2 times the square root of 6, that's going to be the square root of 12, right? But you can also think about what factors there are in 12. Are there any perfect square factors? And there are. There's 4 and 3. So we can look at all the factors of 12 if you want. You've got 1 and 12, 2 and 6, 3 and 4. So you can write out your factors if you want, and you notice that this one is a perfect square. So that's why I'm going to use 4 and 3. Now 4 is 2 times 2. And so if we have the square root of 4 times the square root of 3, it's going to look like this. Square root of 4 times square root of 3. And we know the square root of 4 is 2. So that simplifies to 2. And then the square root of 3 is already simplified. You can't simplify it anymore. So that becomes your answer. So remember, you always want to write it in its simplest form, just like I kept going here. So you can take a look at that one. Let's try a couple sample problems from the book. So we have this times this. It's already written in your book. So we're going to multiply the two numbers that are outside, 3 times 4. And then we're going to multiply what the radicans are, what are inside. So remember, this is not the square root. This is the cubed root. There's a 3. So 9x times 6x squared. So we're going to combine everything or simplify it. 3 times 4 is 12 times the cubed root of 9 times 6 is 54. X times x squared is x to the third power. Okay, so we're still not done. If you recall from 2 weeks ago when we were doing the factor trees, we're going to see what we can factor out of 54. Now remember, because this is a cubed root, we want to look for anything that is a perfect cube, just like we had perfect square, 2 times 2. Well, a perfect cube would be like 8 because you can do 2 times 2 times 2. So I'm going to do the factor tree on this and get all the way down to our prime factorization. And whenever I come to a prime number, I just circle it. 27 is 3 times 9. That's prime. And then 9 is 3 times 3. And that is prime. So what we have here is 12 times cubed root of 2 times 3 to the third power, because there are 3 of them, times x to the third power. Now, you don't have to write them all out like I am with the multiplication in between these two, but I just want to show you how I've simplified it there. Now remember, when you're dealing with the cubed root, that means this is 3 times itself 3 times, but we're finding the cubed root of it. So 3 divided by 3 is 1, which means that this 3 is going to come out of here and come over here, because this is 3 times 3 times 3, and it was the cubed root. So the 3 comes out there. And same with the x. This is x times x times x. 3 x's. So the cubed root of x to the third power is going to be x. And then all you're left with inside here times the cubed root, I'm sorry, I'm writing kind of sideways here, 2. And then we need to simplify what's on the outside here. 12 times 3 is 36, times x is 36, x times the cubed root of 2. I think when you put it in the computer, when you type in your answers, I think this answer in the computer would look like this: 36x, and then I think it's using the caret, even though normally that is for exponents, but you use the caret and then a 3, and then you can do your radical sign and then a 2. I think that's what it's going to look like when we enter it into the computer, and I'll go back through, of course, and check on all of them. Okay, so cubed root of 3 cubed is 3, so it comes out here. And then same with this. The cubed root of x to the third power is x, so that comes out. 2 we can't simplify anymore, so this is your answer. Okay, now let's go ahead and do this one, and then we'll simplify that as well. So we're going to do the FOIL method. So we have our firsts, which would be square root of 7 times square root of 7. That's going to give us the square root of 49, which we know is 7. So you can actually simplify it just below it if you want. Then we have our outer minus 4 times that. Then we have our inner. And we have our last. Negative 2 times a negative 4 is positive 8. And then we're going to keep simplifying. So we simplified that already. And then, oh, you know what? I'm sorry, I think I did a 2. This is supposed to be a 7, not a 2. And then see how this has the square root of 7 and this has the square root of 7? So these two are like terms. So a minus 4 times square root of 7 minus 2 times square root of 7 gives us minus 6 square root of 7. And then we have plus 8, but we can simplify those two. 7 and 8 is 15. So 15 minus 6 times the square root of 7. And that's your answer. I'm going to turn the paper over and do a problem with you so that you can see even one more example. I am picking one literally at random. I didn't even plan to do this, but I want to do this with you so you can see how we do one more. Let me just find one for you real quickly. This is number 20. I don't know if this is one of the ones that you need to do for homework or not. So, hey, let's do it. And if it is, then you got it done. So we have the square root of 3 minus 4 times the square root of 3 plus 2. This is like this second one that we did on the example. So we're going to use the FOIL method on this. You can even write out, I didn't on the example problem, but you can on this if you want. So you've got your first square root of 3 times square root of 3. That's going to give us the square root of 9. The square root of 9 is 3. So I'm going to simplify that in my head. But it looked like this if you need to see it. This is the work that I did in my head, and I'm okay with you doing that amount of work in your head. The rest of it you kind of have to show. If you just go from this to an answer, I might question a little bit and want to see your work of how you got there. But with something like this, you can just go straight to that. Okay, then you're going to do the outers, which is going to be plus 2 times square root of 3. And then the inner minus 4 times the square root of 3. And then last, negative 4, positive 2 gives us negative 8. So then we're going to simplify these two like terms, and we're going to simplify those two like terms. And I'm going to do that in the same line here. So 3 minus 8 gives us negative 5. And a positive 2 and a negative 4 gives us a minus 2. Square root of 3. And the reason I can combine those two is because they both have a square root of 3. So think of it as a label, if you will. So like 2 oranges minus 4 oranges, because these two right here are the same radical or square root. So I'm able to combine it. So this is your answer for number 20. Okay, reach out if you have any questions on this, and we will continue into the next lesson now. Lesson 8.6, this is dividing radical expressions. So here's your quotient rule for radicals, meaning if you see something like this, it's going to be the same as this. So the radical or square root of whatever n is, whether it's 2 or 3 or 4 or whatever the index is, it's going to be the same on top and bottom. So here's an example. The square root of 9 over 64. It's the same as the square root of 9 over the square root of 64. The square root of 9 is 3, and square root of 64 is 8. So this would be your answer, 3/8. Now, when we do division by irrational numbers like this, it's going to be a little bit harder, obviously, than whole numbers. So for this reason, when you have an expression, an answer like this, when you simplify it, you always need to simplify it so radicals are never left in the denominator. So I'm going to show you what to do when a radical is left in the denominator, or when a radical is there to begin with. So here's an example. We have 2 times the square root of 2. Let me see if I can get us down a little more. There we go. 2 times the square root of 2 over the square root of 3. Now, if we are not supposed to leave a radical in the denominator, then I need to multiply this by something so that it is no longer a radical. Now, if it's the square root of 3, and we remember back to our rule that when you multiply a square root by itself, you're going to get whatever the number is in the radicand. So what that means is whatever's on the denominator, we're going to multiply it by that on both sides. Well, top and bottom, numerator, denominator. This is basically like multiplying it by 1, because square root of 3 divided by or over the square root of 3 is 1. But it's going to help us eliminate a radical sign down here. So remember, this is going to be 2 times square root of 2 times square root of 3. And I was going to carry it all the way over, which would be 2 times the square root of 6. And then this is going to be square root of 3 times square root of 3, which we know is going to be the square root of 9, and the square root of 9 is 3. So keep simplifying it till I can simplify no more. And this is your answer. So because we cannot leave a radical in the denominator for our final answer, we need to multiply it by that. When you multiply a radical by itself, you're going to get whatever that answer, that radicand is. So see, the radicand was 3 and the denominator is 3 there. So let's go ahead and simplify 2 examples from the book. So the first thing we can do, and this is where this part comes into play, I'm going to divide those 2 into this. Square root of 3 times square root of 10. These 2 are the same thing, just 2 different ways to express it. So if I need to get this out of the way, because I cannot have a radical in the denominator, I'm going to multiply it by this, by itself. But I also have to do it on top. Remember, math is all about being equal and fair. If I multiply by something here, I have to multiply by something here also. So then this turns into square root of 3 times square root of 10. And this turns into square root of 10 times 10, which is 100. And the square root of 100 is 10. So our answer becomes this. As we're doing more and more of them, I'm skipping this step right here and just jumping straight from here to here. That's what I did here. I went straight from here to here instead of writing that step that this would be. And I'm going to start doing that more. Okay, let's look at this one. So first thing, separate them based on the quotient rule for radicals. X squared. And I bet you can guess what you're going to need to do. We need to get rid of that radical sign down there, so we're going to multiply it by the square root of y. So I'm going to see if you can follow that I'm going to skip a couple of those minor steps. I'm going to multiply those together. So this becomes square root of x squared y over y. Now, we are not done yet, because we have this square root of x squared, which is x. So all that is left inside the radical is a y. And that's your answer. Because we had x squared. The square root of x squared is x. So and these are so not math terms, but it comes out of the radicand or out of the radical sign to the outside. Okay. And then jumping into a couple more types of examples and concepts here. Remember that conjugates, we talked about those in lesson 8.5 and also 2 weeks ago, but they're binomials. They have the same 2 terms, just a different sign in between them. Oops. Funny how I notice all of these once I'm doing the work, but the sings should be the signs between the terms are different. So subtraction, addition. Here's another thing I want you to remember, that when the conjugates are multiplied, the O and the I terms of the FOIL are canceled out. So you're only doing the first and the last. And then also, last thing to remember, these are like your little helpful hints I was trying to help remind you of. When conjugates contain radicals, the irrational terms are the ones that cancel out. So let's jump into what I mean by that. So if we're doing this, if we're doing FOIL, remember, because this is a conjugate, there's an addition, here's the subtraction, but the binomials are the same. They're the same 2 terms. So we're only going to do the first, which is 5 times 5, 25. And the last, positive square root of 7 times minus square root of 7. So it's going to be that. So we have 25, square root of 49 is 7, and then 25 minus 7 is 18. So this simplifies down to 18. Okay, now let's try another one here. So I added this in, so I'm going to take that away just for a second. So this was just kind of reminding you of the conjugates, and this is going to be, this would be the problem. So what we're going to do, because remember, with the conjugates, when they're multiplied, the O and the I terms come out of it, which means that you're going to get a problem kind of like this. So when we multiply this, you might think to multiply by the same binomial here, but you're multiplying by the conjugate. So when you have a term like this in the denominator, you're going to multiply it by the opposite or the conjugate of it. So we're multiplying by the opposite. So this becomes 11 times 5 minus 11 times the square root of 7, because I did distributive property here. So these two got multiplied, and then these two got multiplied. So 11 times 5 is 55 minus 11 over 7. And then I'm going to now do the bottom. And you can do it this way if you'd like also, whatever you want to do. Now this particular conjugate is the same thing we just did here. And we know that answer is 18. So I'm just going to put an 18 there. And then when we did this one, it ended up being 55 minus 11 times square root of 7. That should go all the way over. And that's your answer. It cannot simplify anymore. There's nothing we can simplify. We cannot combine those two because they're not like terms. They're different terms. This one has the square root of 7, and this is just a whole number. Okay, let's try 2 problems here. We are almost done, and then we're going to do 2 problems from the book together at the bottom. So what we have here, we're going to remember when we have a binomial like this, we're going to multiply it by the opposite there, which would be times 4 plus square root of 2, 4 plus square root of 2. You can keep going over to the side. You can simplify by going down. I usually simplify by going down each line. Here I kind of did a little bit down here, and then I moved over there. I was a little all over the place on this one, but on this I would probably create that fraction bar. Now, I'm going to start with the denominator because that's just like this one that we did up here. And I could almost do that in my head, most of it. So remember when we're multiplying conjugates, we're only doing the first and the last. So 4 times 4 is 16 minus square root of 2. Square root of 2 would be square root of 4. Square root of 4 is 2. So this ends up being 16 minus 2, or 14. Now on this one, you're going to use, you can see that you're using, oh, you know what? I just realized, I think I wrote this one wrong. I think that is just supposed to be a 3. Let me double check in the book. Yes, it is just supposed to be a 3. That's going to make life even easier. So go ahead and cross that part out on your notes. I'm so sorry. It's just a 3. So now we're doing distributive property. So 3 times 4 is 12. 3 times a positive square root of 2. And then we're going to go ahead and simplify. There's nothing we can simplify on the top. When I know I'm getting down to my final simplification, sometimes I'll go over to the side like this. 16 minus 2 is 14. And then this cannot simplify. There's nothing we can do to simplify that any further. And that is your answer. Sorry about that mess up. I'm glad we caught it before I was doing multiplying binomials. Now I feel like I need to double check this one. Okay, that one's correct. Okay, so what we're going to do here is, again, we're going to multiply by the opposite. So it's going to be square root of 6 minus 2 times square root of 6 minus 2. And here what you'll need to do is actually the FOIL method of those two. So you can do it off to the side. You can do it down here if you would like. I think I'll do it down here, FOIL. So you've got square root of 6 times square root of 6, which would give you square root of 36, which is 6. So my first is 6. And then I'm going to do the outer, which would be minus 2 times square root of 6. Then my inners, those two, minus 3 times square root of 6. And then my last, negative 3, negative 2, plus 6. So here I'm going to go ahead and actually I can still draw my fraction line and do this down here because remember it's first and last. So square root of 6, square root of 6, it's going to give me 6. Positive 2 times negative 2. And then I'm going to simplify. My denominator is going to be 2. And then these two have like terms, and these two can be combined because they are like terms. They're just whole numbers. 6 and 6 is 12. And then I have a minus 2 times that and a minus 3 times that. So that's going to give me a minus 5 times the square root of 6. And this is simplified. You can't simplify it anymore. Okay, let's go ahead and do 39 and 40, and then we'll end this week's lessons here. So we have this problem here. Remember, we're going to multiply their conjugates and do the same on top. So I'm doing distributive property. 4 times 3 is 12. Plus 4 times square root of 3. Conjugates here, I'm doing the first. 3 times 3 is 9. And the last, negative 3 times square root of 3. So this is going to be minus 3. So in the numerator here, we have a 12 and a 4. Now these are these two terms we cannot combine them. But 12 and 4, this is going to be pulling back to lesson or chapter 7. 12 and 4 have something in common. So we can factor something out of this binomial here. We can factor a 4 out of it. So if we factored a 4 out of that, we're basically dividing this by 4, which becomes 3. We're dividing this by 4, which just becomes square root of 3. So we factored that out. And then simplifying the bottom, 9 minus 3 is 6. So then I'm going to be able to simplify those two. 2 goes into each. That becomes a 2. That becomes a 3. So then now I'm going to go back. Let me rewrite it. And to simplify it, I need to do distributive property. So now I'm going to go back. This becomes 6 plus 2 divided by, or times square root of 3 over 3. So this is where we combined a lot of chapter 7 and what we've been doing in chapter 8. That was a lot. Let me just try and unpack that for you real quickly. So first thing, we multiplied the conjugates, the binomial that would have the opposite sign, same terms. So then we get to here. When we look at this binomial up here, I can even put, if that helps you to see it more as a binomial. Looking at this binomial, I can factor something out of 12 and 4. Something that 12 and 4 both have in common is a 4. So I factored out of 4, which meant I divided 12 by 4, which became 3, and I divided this term by 4. Let me show you what it looked like. These cancel out, and it becomes just the square root of 3. And I put my 4 out there. 9 minus 3 is 6. So now I have a 4 and a 6. A 4 in the numerator, a 6 in the denominator, and I can simplify that. 2 can go into both 4 and 6. So 4 divided by 2 is 2. It's just simplifying fractions, right? 4/6 as a fraction simplified is 2/3. So that's what I'm left with, a 2 and a 3, or down here, 2 and a 3. And then I'm not going to leave it in this form right here. I'm going to actually do distributive property. 2 times 3 is 6. 2 times square root of 3 gives you that, and then same denominator. Lastly, we're going to do number 40, but before we jump into that, I want to do a more simplified version here for you. Because there were no examples really other than kind of this one in the book to go over for when you handle problems like number 40. So notice the difference between 40 and all the other ones we've done is that the index is 3. So whenever you are rationalizing denominators and they have a larger indices like 3 or higher, you're going to want to make sure that all your exponents, whatever your exponents are in here, they need to be made in such a way so that they're divisible by the index, which in this case is 3. So let's go ahead and first break this down. Okay, and then we're going to take 18, and I'm going to kind of move the paper and do it up here. And we're going to do prime factorization with it. So that means that this ends up being cubed root of 7 divided by cubed root of 2 times 3 squared. Okay, and then what we want to do to that is we want to make sure that whatever, oh no, this was a 2, I'm sorry, this is a 2. That looks nothing like a 2, but just know that that's a 2. Please change it. Actually looks better on the camera than it does in person here, but that is a 2. Now we want that exponent to be divisible by 3. So that means we're going to think about what are we going to be multiplying this by here. So let's go ahead and we need to multiply this by a cubed root. Well, if we want to get rid of both of these actually, because remember we can't have the radican or a radical on the denominator. So we need to get rid of the whole thing. So this needs to have an exponent right now. It just has an exponent of 1. I'm going to go ahead and just write that in so you can see. And we need to multiply it by something that is going to make this have an exponent of 3. So that's actually going to be 2 squared. Because remember, when you multiply exponents, you add them. And then this needs to have an exponent that's divisible by 3 as well. And it's already a 2, which means we just need one more. So it's just going to be 3 by itself, or to the power of 1. So that means if we multiply this one by it, we have to multiply the top. So I'm going to kind of then go down here. I was trying to show you the progression there, and now I'm going to move this and keep simplifying it down here. So we are multiplying those two right here. So now we would have multiplying those two right here, cubed root, all the insides, 7 times 2 squared times 3. And I'm just going to leave that for right now. And then we're going to multiply the bottom, or the denominator. So 2 cubed times 3 cubed. And remember, because those are divisible, the cubed root of 2 cubed is 2. And the cubed root of 3 to the third power is 3. And then up here, if we were to combine these, this would give us, let's see, oh, this is supposed to be squared. I'm sorry, man, I am really messing up. I'm sorry about that. So that's going to be 4. 2 times 2 is 4. 4 times 7 is 28, and 28 times 3 is 84. So simplified, this becomes the cubed root of 84. And then on bottom, that becomes 6. So our answer to all of this is this answer right here. Okay, now I feel like we can jump into this. So remember, whatever you do, you want your exponents to be divisible by whatever your index is. In this case, it's 3. So we had to add on some terms with exponents here so that they would end up divisible by 3. So we're going to do that same concept over here. So the first thing we're going to do is using the quotient rule for radicals. And what we need to do is make sure that both of these, because we can't leave the radical sign or the cubed root sign there on the denominator, in the denominator on the bottom. So that means we need to make sure we need to multiply something by this that we can find the cubed root of. So that's just going to be 2 to the 3rd power, right? Which would be 8. So we can do 8. Thinking differently with numbers. If you have a cheat sheet, it will show you maybe something kind of like this. So 2 cubed is 8. 3 cubed is, I think it's 27. 3 times 3 is 9, times 3 is 27. 4, we might be getting further than I can go. No, that's 64. 5. Wow, I'm going farther than I thought. 5 times 5 is 25, times 5 is 125. Okay, I'm going to stop there so I don't embarrass myself with lack of mental math here. But you can see cubed roots here. Now we need to find something that, with this 2, was the closest next thing that we can get to have a cubed root would be 8. So what am I going to multiply this 2 by to get an 8? And that's going to be 4. So 4 and 2 are going to give me 8, and I can do the cubed root of 8. Okay, now I need to make that b so that it will have exponent that is divisible by 3. So I need one more b. So I'm multiplying this by b. That means I'm going to multiply the top by that as well. And then I'm just going to go ahead and simplify. And like I said, sometimes you can keep simplifying all this way. Sometimes I go this way and then I go down. But simplifying, sorry, this is multiplication here. So if I multiply those two, I'm going to go ahead and just do it on this line. I would get the cubed root of, we're going to put the number first, 4ab. And then on the bottom here, we would have the cubed root of 4 times 2 is 8. B squared times b is b to the 3rd. Okay, then simplifying this one, this is going to stay the same right here. We cannot simplify that. But this we can. The cubed root of 8 is 2. And the cubed root of b to the 3rd power is b. And this is your answer. So the key, oh, I'm sorry about that. You just missed the whole denominator part. The key to this is when your indices are 3 or higher, 3, 4, 5, whatever it may be, you need to make sure that all of your exponents are divisible by 3. So whatever you have to get so that this becomes b3 over here, it's multiplying it by a b. When you have a number 2, if you have a little cheat sheet like this, it will help you. Okay, 2 cubed is 8. So that means it needs to be an 8 inside here. What am I going to multiply 2 by to get an 8? It's 4. So that's how you can find out what you're going to be multiplying. Okay, I know that is a mouthful. I'm fully aware of that. And if you take the chapter review and you don't do well on it because this week you're doing 8.5, 8.6, and then you're doing chapter review and test. And if you just absolutely don't feel ready for that test, let me know, and I can try and rearrange some things where we can do some work together, or do a Zoom meeting or something, and make it so that it's a little bit more understandable. Look in your book also. Go slowly. Look at the problem and then look at the answer. And I've given you enough examples to help you, I believe, with all of the problems in here. So look at the examples I gave you and see how I get from this step to this step, and from this step to this step, and then this step down to the answer. Carefully look at each one and then apply that to the problems that you're doing. That's what I do when I come across a problem that I can't do. If there's an example problem, then I look at the example. How did they get from A to B, B to C, and C to the answer? And I try and apply that same concept. So go ahead and try this. And then remember next week that we will be doing, I think we are jumping in to chapter 9. So we'll see the test. I believe the test is all on Canvas. So I can take a look at it, and then we will not have class next Monday. So I'll be doing more videos for class. And then when we come back together, maybe we can carve out some time there to go over any problems that you may have struggled with. So bring questions with you if you have any. Okay, good luck.